I'm Sato. Currently, I'm the Deputy Director of the RIKEN R-CCS. So I got a new job. We started the quantum HPC hybrid computing platform division in R-CCS, and I'm now in the division director. Today, so I'd like to talk about quantum computing, quantum HPC hybrid computing platform project in our the RIKEN R-CCS. So here, there is RIKEN is the big research institute. There is the many the quantum computing research. So first one is that the RIKEN Center for the Quantum Computing. There, so they are developing the actual the quantum computer using the superconductive qubit. So this is a picture of a chip and a system. And this is ours, and we are developing the quantum computer simulators using the Fugaku for the large scale the quantum computer simulation. And we are the research and development for hybrid computing system with the Fugaku and quantum computer. And as you know, the Fugaku system development is finished, and the feasibility study of the next system is going on. And one of the important topics for the next system is that how to integrate the quantum computer or another advanced devices to the next machine. So it means that we are doing a kind of feasibility study also for integration the quantum system to the next machine. And here is another, the RIKEN has many the researchers on the physics and the chemistry, and the items is the physicist. And RIKEN Quantum is a group of the people, researchers who are interested in quantum computing. So this is a list of the quantum computing researches in the RIKEN R-CCS. So first one is the RIKEN project for research DX. So, and next one is the NEDO project. So this NEDO is the name of the funding agency. Recently, we got new funding for the quantum computing, quantum and HPC hybrid platform project. So name is very long, but I'm going to talk later more detail. So, and this is the figure of RIKEN project called the TRIP. And there is the three pairs, three items. The one is the high quality data acquisition, and this is about the data and the integration. And the next one is that AI for science. So, and maybe you got a lot of the information yesterday's the Satoshi's talk. And the third one is the expansion of the computationally bidable region. That means the quantum classical hybrid computing. So this is the main motivation for our the quantum and HPC the platform project. And to conduct the TRIP project, the quantum and HPC hybrid computing, we started the new division. There is the 3 unit. The one is the software development and the software stack, and mainly for the system software, and read it by me. And next, the unit is working on the simulation. Simulation is a very important tool for the quantum computing. The last one is the operation. So we are aiming to build the quantum HPC hybrid computing platform and operate for the users. So there is no the application unit, but we expect many the researchers in RIKEN who are interested in quantum computing will be our potential users for the platform. So we are going to collaborate them for the quantum HPC hybrid computing. So let me talk about why we need the quantum computing and HPC. So from the HPC point of view, so I'm not originally the HPC guy, as you know, and from the HPC point of view, the quantum computer is kind of the accelerators. That means one of the devices to offload and useful computation from the large HPC application, maybe like a GPU. But the biggest difference is that GPU is the accelerators which is attached to the every nodes in a supercomputer. But I think this is the final goal. But currently, the quantum computer is needs a very the strict the environment to operate, and that means, for example, the superconductive qubit case. Superconductive qubit needs a very, very low temperature to operate. Maybe in a very, very for futures, every node has the quantum computer like a GPU, but this is not so. No, this is too early to think about. And supercomputer is useful for large scale the quantum simulation. So simulation now is a very important tools to design the quantum computer algorithms, and also for the error mitigation, because the current quantum computer is very noisy. So to mitigate error, I think the simulation is also important the tools to investigate what kind of the noises is affect to the result of the quantum computer. So the quantum simulation can with the noise, the simulation for the physical devices will be also also useful. So how much time we need to simulate? So I think the 20 or 30 qubit can be simulated by the PC, very small machine and a workstation. But it's more than 50 qubit that we need the more large scale the computation resources. So currently, Ito-san's team is working on a state vector simulation for the 50 using state vector method. The largest qubit to simulate is that the 50 qubit. So if more than the 50 qubit and the 100 qubit, we need another algorithms like in tensor network method. So anyway, if the number of qubit is increasing, we need more computing resources to simulate. So another motivation is that error mitigation. So because the current the quantum machine is the NISQ machine, that means that it has the noises. So we need techniques to mitigate the error after the quantum computing. So also 20 or 50 the qubit can be analyzed by the conventional servers and the GPU. But I think if we are going to have more qubit, more than 100 qubit, we need more computing resources. So, and the optimization or cutting, knitting, and the large-scale qubit need the HPC. And the previous speaker also about the variational algorithms. That is that need the interaction between the quantum computer and the HPC. So to do such kind of the application, such kind of the algorithms, so we need more tighter interaction between quantum computer and the supercomputer. But the one thing I'd like to note that, so in a supercomputer, current supercomputer architecture is the kind of the bandwidth-oriented design. It's not so improved latency. So that means, if we are going, if the more the latency-oriented the operation is required, then supercomputer will be a kind of more tight integrated GPU. So, and recently, from the November 1st, and from the November of last year, we started a new project, which is called the GHPC Quantum Project, for development of the technologies and the platform for hybrid and quantum and HPC hybrid computing platform. So this is the one-page slide in a very, very busy. The title of the project is the Research and Development for Quantum Supercomputer Hybrid Computing Platform for Exploration or Uncharted the Computable Capabilities. So the project is will conduct in research and development for software to integrate the quantum and HPC. And using that software, so we would like to design and implement the platform and operate the platform. And using that platform, as well as demonstrating the superiorities of the quantum HPC hybrid application against the application only by the supercomputer. So that means we want to we want to demonstrate a kind of the advantage of the quantum HPC computing. And this funding is coming from the Ministry of the Trade and the industry. So we are another things we requested is that develop the technologies to open the quantum HPC hybrid powers to the 5G the internet application. So, and again, the project is the 5 years, and the member is RIKEN and SoftBank. SoftBank is the IT company in Japan, with the collaboration of the University of Tokyo and the Osaka universities. The mission is the development of the system software, and also using the system software, the quantum supercomputer hybrid platform will be designed and built, and the system to enable the exploration of the new the computable capabilities. And also, we are aiming to demonstrate a kind of advantage of the quantum and the HPC application. And also, we are going to provide the kind of the cloud softwares to open the HPC and quantum application to the through the internet. So this is the topics. This is a figure. So this is the classical side. This is the classical side, and this chart is the quantum computer and simulators. So we are going to develop the quantum HPC hybrid system softwares to connect between the conventional digital computer and the quantum computer. The modular quantum software library will be developed in Osaka University. So maybe next the speaker is talking about these topics. And again, the cloud computing technologies for the quantum supercomputer hybrid platform will be developed by the SoftBank. So our project is consists of the 9 working package. The one is the middleware, RPC middlewares and API for hybrid. And the second one is the programming environment. And third one is about the co-schedulers. So I think as I pointed in a previous speaker, the co-scheduler is one of the very important topics for collaborating the supercomputer and the quantum computer. So far, the number of qubits is 20 or 10 or 20. So at that time, the classical side usually is a kind of the PCs and very small computing resources. But if we are thinking about in a kind of integration and HPC and the quantum, HPC supercomputer is also very important resources. So we need a co-scheduler. And the working package for the modular computing software libraries. And the working package 5 is the integration and the operation. So later, I will show our plan for the platform. And working package 6 is about simulators, and the 7 is the optimization algorithms and techniques for quantum and HPC hybrid computing. The number 8, the working package is the very important working package that because that they are supposed to working for the application, and if possible, they will demonstrate an advantage. And the 9 is the cloud software, and 10 is the kind of promotion of the HPC, quantum HPC application for the industry people. And this is the pictures. Okay, I just skip. And this is the overview the quantum quantum computer and supercomputer hybrid computing platform. We are going to install 2 different type of other quantum computer. The one is the quantum computer from IBM, and this system will be installed in RCCS in the same building of in Fugaku. So, and we plan to connect them the first low latency network maybe this is the InfiniBand. But, and one of the topics we are going to explore is that how to make use of this first in the low latency network to accelerate and integration of the quantum and HPC. And also we will have the GPU system, and this is connected by the RCCS local area network. The ion trap machine will be installed in a different campus. This is a Wako campus near to Tokyo, and because the ion trap machine is very delicate, and this machine needs the more the special environment, so special room. So because of that, so we decided to install an ion trap machine in Wako. This machine will be the from the Quantanium. And our partner, our collaborators, University of Tokyo and Osaka University, has the supercomputer. We have planned to connect this supercomputer to this platform through the internet. This is the SciNet academic, the wide area network. So, and the users are going to in these machine, the Osaka machine and the Tokyo machine, and we are going to support in a more hybrid environment to make use of the two kind of the quantum computer. So, currently many the quantum computer researchers doing like this. So making log into the cloud and making the quantum programming and generate some kind of intermediate form, and this intermediate form is sent it to the quantum machine and execute it, and the result is coming back and analyzed. But in near futures, in our platform, we are aiming to programming the environment in a kind of a single source. The quantum computer hybrid program is compiled and divided and to generate two kind of program. One is the quantum, and another is the supercomputer. And these two, the job is the co-schedule. So we would propose two kind of two level of the programming model. The one is the workflow, another is the asynchronous RPC. So I think in general, the task and workflow like a high throughput computing system is something like this. So users write in a workflow like this, and one of the tasks is the quantum computing, and this task is using the QPU. I think this kind of the workflow is very useful for AI or deep learning in the quantum learning application. And inside of the QC task, so we are aiming to support in asynchronous RPC. So this is the figures. Okay, and I think, for example, this is the execution of the HPC application, to which using a lot of nodes. The one of the node is going to be host, and pre-processing and execution of the libraries and RPCs for the quantum computing. And post-processing, maybe these phases can be iterated, and we would like to design a support in an RPC API to connect the supercomputer and the quantum computer. So currently, the many users using this phone, but okay. But we like to support the supercomputer like this. Okay, so I think a requirement of the quantum HPC, the remote procedure call as an API to the QC. The things is first one is the authentication system for users access control. The second one is we are going to have the more high-speed interconnect. So we should support that. And second one is, again, very important topics. RPC is aware for the core schedulers. And third one is language. So currently, many other quantum computer users using the Python-based framework, like a Qiskit and the keyboard or something like that. So, but I think to support many HPC users for quantum, so we need more traditional language like C and C++, modern, as well as Python. And support an HPC programming model as an MPI and workflows. So currently, we are doing that very preliminary implementation. So usually, currently the user interface, the interface for an execution is defined by the REST API. So to connect to the REST API, we are doing the design some RP system to connect between the supercomputer and the quantum computer through the REST API like this. Okay, this is the last one, and I'd like to discuss with you what is the quantum computer now. I think some of types of the quantum computer hardware is more than 100 qubit. So this number cannot be simulated by even a supercomputer anymore. Of course, if you choose another simulation algorithm like a tensor network, you can simulate. But basically, it's difficult to. It's going to be very difficult to simulate in a classic the supercomputer. And I would say the quantum computer technology is now in engineering phase. So number of qubits will be increased by the year and year, like Moore's law. But the 100 qubit, the current the supercomputer, superconductive qubit quantum computer, this number is not large enough for practical use. Of course, the fidelities is getting improved, but still it is a NISQ machine. And many people is expecting the FTQC. That means that in a quantum computer without noise, this machine will be available more than 10 years, a little bit ahead. So if we are thinking about an application using the 100 qubit, this is not enough. So, for example, the optimization program like annealers or the QAOA, and this is very promising areas, especially for the industry people, but it is not clear. These are better than the semi-optimal solution by the supercomputer. So to find is the good application, the quantum computer with this number of 100 qubit is not so easy. And from viewpoint of a supercomputer viewpoint of view, a quantum computer is accelerators. So many current the computational science application may use the quantum the computer as accelerators. So 100 qubit is not so enough, but I think I believe that within 5 years, the number of qubits going to be the 100. No, it's 1,000. So I think we have to get ready for near futures the quantum computer using the current the 100 qubit the quantum hardwares with HPCs. So let me finish my talk with our schedule. Our project is already started, and installation of the real the quantum machine in Japan and will be second quarter of 2025. And we are aiming to make the hybrid computing platform at in 2026, and hopefully we are going to operate them to demonstrate a kind of advantage of hybrid QC and hybrid application. And the project will be ended in 2028. And after that, the SoftBank is supposed to be doing kind of business using the platform. So this is the last message. So we are welcome to international collaboration on the quantum HPC hybrid computing platform. Thank you very much.